Hello everyone, welcome back to the channel. In this video, I'm going to record myself attempting the May 2021 IB Physics Paper 1 Time Zone 2. So this is the multiple choice paper that has been fairly recently released. I've done the Time Zone 1 paper already and I did kind of poorly. I got 35 out of 40, which is quite good if you're a student, but I'm a teacher and I made some pretty terrible mistakes. But then I was doing it under time constraint when I was recording the video, a bit nervous, not really checking my answers. So, but then I explained my mistakes by the end of the previous video, and I hope you guys learned from both the right and wrong answers. And I definitely want to redeem myself for this paper, and in the process, again, illustrating some like exam strategies and techniques in solving different types of physics problems. Let's just jump into the paper. First question is about uncertainty. So let me skip this. A student measures the length and width of a rectangular table topped with lengths and widths provided with uncertainties. And you have to calculate the perimeter. And perimeter involves just additions of some of these sides. When you add quantities with absolute uncertainties, the final quantity, which is the perimeter, will have an uncertainty that is the simple sum of the uncertainties of the lengths and width involved. So the answer should be 0.6 because you need to double the width and double the length. Question 2, the minute hand of a clock hanging on the vertical wall has a length of 30 cm. The minute hand is observed pointing at 12, and then 30 minutes later pointing at 6. What's the average velocity and average speed of point P on the minute hand? So average velocity, you just look at the straight line distance between the starting and final points. So it will be, well, the length is 30 cm, so 60 cm over 30 minutes, so 2 cm per minute, vertically downwards. So A should be already the answer. But then for average speed, you look at the arc length. So 2 pi r divided by time. So 2 pi times 30 divided by 30. No, 2 pi times 30 divided by 2 first because it's a semicircle, and then you divide by 30. So pi cm is also consistent. But in any event, the answer is A. Question 3, a block rests on a rough horizontal plane. With a force applied, there is a coefficient of friction mu d giving rise to a frictional force. And the force P is doubled, and how would that doubling the pull force affect the frictional force? It turns out this is just a matter of understanding that the coefficient of friction depends on only the material. The friction itself will also depend on the normal reaction force, but the normal reaction force is unchanged even if you increase the horizontal force. So the answer should be A. Question 4, a projectile is launched at an angle above the horizontal with the horizontal component and vertical components given. They're asking you how the velocities change. In the situation where air resistance is negligible, the horizontal component should remain constant, which means choice D should be the answer. And yep, because everything else is wrong. The vertical component will decrease in magnitude to 0 as the object rises to the top, and then it will become more negative at the linear rate because that's how gravitational acceleration works. Question 5, a person with a weight of 600 newtons stands on a scale in the elevator. What is the acceleration of the elevator so that the person appears heavier than she is? The equation for, well, if the scale is heavier, that means that the support force exceeds the weight. So you're looking at 900 minus 600. So the up force minus a down force would represent the resultant force acting on the person. And this is now this is the time to use F equals to MA. But the mass of the person can be inferred to be just 600 divided by 10, which is 60. Therefore, the acceleration should be, well, 300 divided by 60, which is 5. And then because the support force is stronger than the weight, you can infer that the acceleration must be upwards. Okay, question 6. 2 identical blocks, each of mass m and b, travel towards each other on a frictionless surface and then undergo a head-on collision. was definitely true after the collision. The total momentum should be 0 if the masses are identical and have equal and opposite velocities, because mv plus negative mv is just 0, and then conservation of momentum in the absence of any external force, such as having no friction on the surface. The final momentum should be 0. The momentum of the individual blocks actually depend on the elasticity of the material that makes up the blocks. So you can't infer whether A or C is correct, and then D is just plain wrong. Question 7. A similar question has shown up in May 2016, I think, having these kind of graphs. The graph shows the variation with distance of a horizontal force. So a force acting horizontally will do work on the object. And they also have a constant frictional force. Okay, this is a more difficult version of the 2016 question. But then what you need to recognize first is that the area under these triangles would represent the work done by the horizontal force on the object. That corresponds to the potential gain in kinetic energy of the object. The force is applied. Well, let's get this snipping too. The area would be 80 times 5 each of them. Well, 80 times 5 divided by 2, that's a triangle, right? 80 times 5 divided by 2 is 200. So 200 times 3. So 600 joules of work have been done by the horizontal force. But you also have a constant frictional force of 2 newtons acting effectively over 50 meters. And that corresponds to 100 joules of work dissipated due to the action of this friction. So the net gain of the net work done on the object should be 600 minus 100 should be 500. And the object initially at rest means that the final KE just equals to the gain in KE during these, well, due to the action of these two forces. So the final answer should just be 500. 8, a sample of oxygen gas with volume and temperature given. If we heat the gas so that the volume is doubled and the temperature is constant. So this is the VT direct proportion relationship, but then the classic trap is that the temperature is not given in kelvins. You have to convert 100 Celsius into Kelvin, so plus 273, so that's 373. And then you double that Kelvin temperature. So times 2, that's 746, and that's quick math. Minus 273, and that's 473, I guess. And they want to be special and round it down. So sure, so 470. And yep, answer is B. Question 9, this is clearly a ratio problem, and it's not even about mixing because you've got 2 isolated samples of gases, and you can just use, they use N molecules. So you can use PV equals to NKT twice in ratio format. I'm going to modify the top because the top can represent Y and then the bottom can represent X. PY is something that we are trying to figure out. The volume of Y, well, identical containers implying that V should be able to cancel. N versus 3, and so there should be a factor of 3, and then the N's cancel. K is a constant, so K cancels. And then T versus T over 2. And then T cancels, so PY over PX just equals to 3 over 2. Answer is C. Question 10. A piece of metal at 100 Celsius is dropped into an equal mass of water at temperature of 15. The specific heat capacity of water is 4 times, so this is a classic mixing situation. And it should be assumed, it should be an inverse proportion weighted average kind of situation. If you guys don't understand what that means, I'll just use standard equation. So MC delta T for the metal should equal to MC delta T for the water, with the M's cancelling because the masses are equal according to the question. put in the bracket first because the C values for the two substances are not the same. So C, and then the metal goes from 100 to something. And notice that the 100 is actually the starting temperature and not the final temperature. But for this mixing situation where you the final temperature should be some intermediate temperature, it will be better just if you just use the higher temperature and subtract the higher temperature by the smaller temperature to get the energy released by the metal or by the hot object in general. And you can now cancel the C's and then just expand. Equals to 4t minus 6t. 160 equals to 5t. 32. And when I say inverse proportion with the temperature difference, so the difference between in the temperature between two systems is 85. And what you can do is to divide the 85 into 1 plus 4 into 5 portions. And then the final temperature should be, the difference between the final temperature should be in the ratio of 1 to 4. If this is my horizontal temperature scale, 15 and no 100. Because that's how mixing works. Question 11 now. The bob of a pendulum has an initial displacement x0 to the right, and then you release it and allow it to oscillate. They give you the displacement time graph, pretty standard. At which point is the velocity of the bob at its maximum magnitude directed towards the left? I think they're just asking for when the gradient is most negative. So the answer should be C, and answer will be C even if the object is not undergoing excitation. Question 2, which graph shows the variation of amplitude with intensity? So it's just I directly proportional to amplitude squared. Simple facts, choice B. Unpolarized light of intensity I0 is incident on the polarizer. And you rotate the second polarizer. What's the maximum value of intensity emerging from the second polarizer? So the best way to transmit polarized light is just to line up the transmission axis between the first and second. The trap here is to recognize that the unpolarized light will have its intensity cut in half regardless of the orientation of the first polarizer. So I hope the answer is just B. Yep. Question 14, the frequency of the first harmonic in the pipe is measured. An adjustment is then made that causes the speed of the sound of the pipe to increase. What's the true for the frequency and the wavelength of the first harmonic if you increase the speed of sound? Well, the first harmonic wavelength depends only on the dimension of the pipe, which is unchanged. If you double the speed without changing the wavelength, and you double the frequency because speed equals the frequency times wavelength. Five wires, cylindrical wires with a lot of fractions. Okay, let's just do it. It's not difficult, but it's just annoying. So the equation of interest is R equals to rho L over A. And I think the formula book gives you this. But because R is a subject here, so Rx over Ry equals to, for X, everything is standard. And then for Y, all quantities would have a multiplier. L over 2. The area is actually decreased by a factor of 4 because area equals to pi r squared. If you halve the diameter, you also halve the radius, but then you quarter the area. And if you clean up all these ratios, the rho LA are all gone, then you end up with 1 over half times half divided by a quarter. And I'm stuck. Because I made a mistake. I was looking for the answer of 1. Just okay. Now I discovered my mistake. So thankfully, that's actually a blessing in disguise. Like whenever your one answer is not one of the choices, then The physics god is actually smiling on you. Should be 2L here. And the factor of 2 remains. So half and 2 cancel. So 1 over a quarter. So it should be a quarter. Question 16. An ion moves in a circle in a uniform magnetic field. What single change would increase the radius of the circular path? The equation for this is derivable from the formula book. Because for circular motion, is the magnetic field generates a magnetic force which is responsible, or which serves as a centripetal force. So the radius can equal to mv over vq, and this is a very important, simple but yet important derivation that you need to be able to perform on the spot. So to increase the radius of the circular path, you can increase m or increase n, increase v, or decrease b or decrease q. So clearly C is the choice. Question 17, moving on. Circuits. So you have a variable resistor in series with a fixed resistor. What are the initial and final voltmeter readings when the variable resistor is increased from 0 to R? Oh, interesting. Should just be 6 to become 3, right? Because at first you have one single resistance like using up all the EMF or experiencing the entire EMF. So the R should just begin with 6. And then by the end, when the variable resistor also acquires a resistance of R, then you have 2 identical resistors sharing EMF equally when they are in series. This is much more straightforward than the timezone 1 paper for some reason. And also saw the same for chemistry. Okay, question 18. Magnetic field lines are an example of weird nature of science questions, but I think B is a fairly straightforward answer. Let's hope it's correct. Okay. 19, an object moves in a circle of constant radius. Values of centripetal force are measured for different values of angular velocity, and you plot F against omega. So something against omega, not quite F against omega, but the equation is in the formula book, I think. So if you plot F over omega squared, that's a straight line. Here you plot omega without the square. So basically just square root both sides. And the gradient of this graph would be the square root of the product of MR. But that's not what they're asking. And yeah, let's just move on. Question 20, example of pure radioactive nuclei initially has N0 atoms, and then initial activity is A0. The second sample of the same nuclei initially contains 2N. So the activity will become 2A because the relationship between A and N is A equals to lambda N, with A and N values, the initial values. So A0 for the new sample, which is equal to 2 lambda N naught, which is 2A naught. And then being the same type of radioactive nuclei, the half-lives would be the same. So 2A after 3 half-lives, so 2A becoming A, becoming half, and A becoming quarter A. Because both N and A will follow the same half-life halving pattern. So I think B is correct. 21, they want you to list the wavelengths of decreasing frequency. So high frequency is short wavelength. They recognize that these arrow, the length of the arrows are directly proportional to energy and not the wavelength themselves. So lambda 4 should have the highest energy and hence the shortest wave, and also the highest frequency, I guess, because they're asking you to rank the frequency. So lambda 4 has the highest frequency for sure. And they want you to rank them in decreasing frequency, so lambda 4 goes first. So lambda 3 is the end for sure. So it should be lambda 4, lambda 1, lambda 3. They just very weirdly represent the question, but not difficult at all. 22, during a nuclear fission of X into Y and Z, energy is released. The binding energies of X, Y, and Z are Bx, B1, Bz. What's true about the binding energy per nucleon? Well, during fission, you're fissioning very large nucleus in the intermediate size nuclei, which are more stable. And if a nucleus is more stable, it's got higher binding energy per nucleon. And I think A is correct. This is definitely wrong. You don't add binding energies like this. And you don't add binding energy per nucleon like this. And you can add binding energies, but you also need to worry about the mass defect during a nuclear reaction. And moving on. Exchange particle for X. You are combining a negative particle and a positive particle together. So X must be neutral. And this is also a lepton-lepton interaction. So it has to be a neutral particle. Meson can mediate strong forces, and gluon also mediate strong forces. Leptons are not exchange particles. So it can be a virtual photon, I'm guessing. On the paper 2, without the choices, I may put down the Z0 particle. If there's another very common particle that can mediate a weak nuclear force. But this can also be, this also represents an annihilation reaction where electrons and positron, an electron and a positron destroy each other, and then with the energy carried as a virtual photon used to make a new pair of particle. But any event, let's just move on for now. What's the main role of carbon dioxide in the greenhouse effect? It absorbs outgoing radiation from the Earth mostly. And that's just a matter of knowing your greenhouse effect facts. 25 windmill, turbine blade length. Yeah, that's windmill, okay. Second turbine designed to produce a power of that, and let's just use ratios again. The equation that we're going to use in ratio format is this. Density, speed cubed, and the formula book has this, but I wrote pi r squared because I foresee the need to use pi r squared because the length will serve as the radius of the circle that the blades sweep up. The halves are going to cancel. I just write pi r squared u. Density of air. And this equation again is on the formula book. The new power is halved compared to the other power. Pi's will be gone. Blade length. A second ideal wind turbine is designed. So L new is something you're trying to figure out. And then the density of the wind is most likely going to be the same because the wind density, air density is, yeah, density for the air, not wind, but density is supposed to remain constant. But then the speed is going to decrease by a factor of 2, so with the cube. Oops. So this translates into half because the P's, Pi's, air density, and B all cancel. And we have the L ratio squared times 1/8. So the ratio should be 2. Okay, 26, a mass spring system oscillates vertically with a period of T. And you move the setup to a new location where the gravity is weaker. The equation for this is quite straightforward. It's in the formula book. T equals to 2 pi L over G. So T nu over T would, well, pi and L are the same. Wait, I'm joking. This is a pendulum. They give you a mass spring system. Whew. It's M over K instead, so the gravity has no influence. Because only the spring constant affects the period. So the period just C. Wow, that almost fell for it. Okay. 7, light passes through a diffraction grating. What quantity must be decreased to improve the resolution of the diffraction grating? Grating resolvence equation is lambda over delta lambda equals to the resolvence itself, and I don't think the resolvence is physically meaningful. This is the order, and this is the number of slits, and that's important. When you want, I guess, when you want to improve the resolution, so you want this to become bigger. You either increase M or you increase N. But then they want you to decrease something. I guess if you decrease the number of grating lines per millimeters, well, if you decrease the grating spacing, that means that you're fitting more lines within the same length. So the same beam width will end up illuminating more slits. So the answer should be A. Question 28, a train is moving in a straight line away from a stationary observer when the train horn emits a sound of frequency f0. So this is a, well, let me screen cap this first. The equation for a moving source and a stationary observer is F equals to F0 times V, and the V plus V source. It's plus because the train is moving straight away from it. And I think all you need to do is stop numbers in. Because the speed of the wave. So those are the speed of the wave. Times V over 1.1B. V's clearly cancel. And then it asks me for the frequency of the horn as heard by the observer, and that's this F. So B should be the answer. Uh, 29, monochromatic light of wavelength lambda passes through a single slit and produces a diffraction pattern. So to decrease the width of the central maximum, so the single slit diffraction profile looks like this. That's kind of badly drawn, but it's okay. So this is the angle, the first minimum angle was given by this equation. So to decrease the width of the central maximum, you basically need to decrease the theta. So to decrease the theta, you either decrease the wavelength or you increase the B. So the answer should be C. Okay, question 30. An object of mass released from rest near the surface of the planet has an initial acceleration of z. Gravitational field strength should be just that, right? Because that's like definition. Gravitational field strength equal to gravitational acceleration. Okay, weird. I expect this to be question 2 or question 3 and tested in the context of kinematics, but not as a question 30, which is supposed to be them testing you on topic 10 stuff. Let's just move on to 31. The magnitude of the change in the electric potential between X and Y. There's an equation that you need to be aware of, V equals to ED. The D would be the distance along the field. The distance OX is X and the distance OY is Y. So the distance OY has nothing to do with this, so it should just be EX. Question 32, a satellite orbits a planet X with a speed at a distance r from the center of the planet. Another satellite orbits is the same or different planet at different speed at the same distance from the center of the other planet. Vx over Vy. It's a ratio question again, and the equation of interest here is V orb equals to root gm over r, and that's in the formula book. So G is G. The one you find the V ratio. So everything on top is the quantity belonging to X. So Y has 4 times the mass. But the distances are the same. But the only difference is the mass. So G, M, R are all gone, and then all you have is the square root of 4 sitting in the denominator. So the answer should be 1/2. 33, a parallel plate capacitor is connected to the cell of constant EMF. The capacitor plates are then moved closer together without disconnecting the cell. Okay, what are the changes in the capacitance of the capacitor and the energy stored? Okay. The capacitance itself is given by this equation, and the capacitance does not depend on the voltage. If you decrease the distance, then clearly the capacitance increases. And then the energy stored, well, if you keep the cell connected, then the same voltage will be maintained. Energy equals 1/2 CV squared, I think it's in the formula book. So if you increase the capacitance without changing the voltage, then yeah, energy increases. Question 34 is about AC circuits. Average power is given by, you can use stepping 2 to screen cap the thing first. And then P equals to I squared times R. So P average equals to I RMS squared R. I think this is in the formula book, but I really need to check. But who needs the formula book? Well, I don't need the formula book. But I didn't say that for paper 1 because I did not remember the resolvers equation way back then. But then I recorded that video like just 2 or 3 hours ago, so I still remember resolvents. So you saw that I solved my resolvent problem, no problem, in this paper. But anyways, P average is something that they're asking. Current, the maximum current is 2, and then IRMS has to be the maximum current divided by root 2. You square that. Resistance is 4, so if I just sort this out, 4 divided by 2 times 4, that's 8. Okay, 35. Okay. The graph below shows the variation of time. So this magnet, which oscillates in and out of a solenoid connected to a complete circuit, this is definitely a Lenz's law or electromagnetic induction situation with the oscillation kinetic energy converted into electrical energy. So the oscillation will die down. They give you, let's just read the question first. Okay, the spring is replaced by one that has allowed the magnet to oscillate with higher frequency. So wait, what's the significance of the 240? Well, anyways, let's read it. The spring is replaced with one that allows the magnet to oscillate with higher frequency. Which graph shows a new variation with time the current in the resistor? If the spring, well, let's see the old graph. So the old graph has a period of t. With higher frequency oscillation, the period will shorten and then the amplitude should also increase. Because the EMF and hence the current induced depends on the speed of the oscillator, which will be higher. But would it be higher? They're not changing the spring constant. They just say that the magnet oscillates with a higher frequency. That's weird. But if you change the spring so that the frequencies go up, then does the velocity also automatically go up? Even if they maintain the same amplitude over higher frequency means that the speed will be higher. So I think I'll still stick to A. But this is the first time I have a question which I am uncertain about. So let's hope that this is correct. For the previous paper, there are so many questions I was uncertain about. Okay. But this one I'm doing much more calmly. That's what I feel anyways. Okay. Question 36, the capacitor is charged with a constant current. The graph shows the variation of PD across the capacitor with time. So this is definitely not your standard charging curve because the typical charging curve should be an upside down version of exponential decay. The gradient of the graph is G and what's the capacitors? Wow, that's difficult. I feel it will be difficult. Wow. Just V equals to Q over C. So here, well, you've got V equal to constant times time. Why don't you just M for gradient, maybe? Q over C equal to M over M times time. And we had to bring in current, but the current equals to IT. The times cancel and the capacitance would equal to I divided by M. And M is gradient, which is G. Oh, that's interesting. I think this should be correct. Moving on. Tunneling, assuming energy remains constant, what combination changes in particle mass and barrier length will increase the probability? Smaller particles and smaller barrier length. They've barely tested tunneling, so this is regardless of whether I got this question correct or not, I can definitely add this to my notes. I don't think this has come up before, but intuitively, if you have a low barrier, then it's easier to tunnel, and then smaller particles would probably require less energy to tunnel as well. We'll find out. 28, nuclear number A and nuclear density. That Y has a nuclear number of 2A and the nuclear density is the same because this is the term. Nuclear density is independent of the nature of the identity of the element. It's the radius of the new nuclei that will increased by a factor of the cube root of 2, I think. I'm surprised that they don't actually have that as a choice, as a trap choice. 39, what's true for the Bohr model of the hydrogen atom? Angular momentum of the electrons are quantized. I think that's actually correct already. Wave function is the Schrodinger model, and Bohr has not heard of the wave function at the time of his discovery. Electrons, I think, I'm not sure whether orbitals and orbit mean the same, because in chemistry they clearly mean something different. But even for the Bohr model, electrons do exist in fixed orbitals. But I forgot to color my 37. Electrons will continuously emit radiation. That's the postulate that Bohr makes. Bohr suggests that there are some orbits which causes the electron to not emit radiation, even though it is accelerating due to it undergoing circular motion. So it should be A. Last question. An electron of non-relativistic speed interacts with an atom. All the energy is transmitted to a photon. Electron of speed 2b now interact with the same atom, and all the energy transmitted to a second photon. If you double the speed, then you 4 times the kinetic and its kinetic energy. So all energy is transmitted to a different photons. I think just 4 maybe. And I don't think this needs an orange, but I'll just change it back to black and then check my answers. And do I want to go through any other questions? Probably not. Okay. I don't want to make this video to be excessively long. And that was the first paper. And second paper, let's figure out how well I feel this time. Loading. Failed to load PDF document. That's weird. We'll go back here. Did it take it down for some reason? During the time of recording? Oh, there you go. Okay. This time zone 2, yeah, time zone 2. Okay, let's find out. BAADD, all good. BBBCD, all good. CBBAD, all good. CCBAB, yeah. BADBC, CABCA, ABABA, yeah, a lot of A's. Like, oh, you got perfect, okay. All right, so yeah, I more than made up for my questionable performance in the first paper. All right, so I hope the explanation makes sense. And yeah, I guess that's it for all the science multiple choice papers. I may next do the math papers. And yeah, hopefully I'll see you guys again. Thank you for watching.